The targeted approach to this question would be looking at all the places where we made choices while doing a forward scan. And so let me first delete the backward scans because they are irrelevant over here. And working only with those values. So let's start with 0. 0 plus duration time activity A, which is a reducible activity. So I can indicate all the reducible activities first, which was A, B, F, H, and K. A, B, F, H, and K, sorry. Now these are very crucial to your decision making. So here we start with 0. Now we could go either this way, that way, or that way. And I've decided to go along activity B because I know that there's a choice coming up here first, earlier, compared to at the end of F and compared to the end of H. And there's an activity B that I can reduce, but should I be reducing B? It's totally determined by this edge, which consists of this non-reducible activity. So if I add 0 plus 6, I get 6 at the end of this edge. Now, if I was to reduce this value 8, which I got previously, down to 6, I could reduce one activity, that is B, bring it down to 3, such that I would get the earliest start time at the end of earliest start time for activity E is 3. And if I add 3 to the duration time for activity E, which is 3, I get 6 instead of 8 over here. And that reduces my earliest start time for activity G to 6. So now I go along this activity. So 6 plus duration time for activity G is 4, which is 10 instead of 12 here. Now previously, I had reduced 5 to 3. And if I add, without crashing activity F, if I add 3 plus 4, it gives me 7, which is already less than 10. So it doesn't matter. If I keep F the same without crashing, it's better because any further crashing would still enable me only to make a choice of 10. So don't crash along F because that's a waste of resources. So 3 plus 4 gives me 7 at the end of this edge. And I would choose 10 here. Now I'm coming to a choice at the end of H and I. So let me first choose to work along H, now without crashing. So I usually do it without crashing first and then decide how much crashing is required. So 10 plus the duration time of activity H, which is 6, gives me 16 here. And if I go along ADI, 0 plus the duration time of activity A, which is 7, gives me 7 over here. 7 plus 8 is 15 here. And 15 plus 2 is 17 here. Now, I know that if I came along activity H, it reduces maximum down to 16. So along that path, ADI, I have to reduce the reducible activity only by 1 so that it is equal to 16. Currently it sits at 17. So I reduce A by 1 to 6. And that makes this 6. 6 plus 8 is 14 here. And 14 plus 2 is 16 here. And so the choice is, instead of 18, I would say 16 here. Now, K is a crashable activity too, but should I crash? It is determined by the other choice. Because J is not a crashable activity. So I told you, always come along the path which has got the non-crashable activity, because that is the one that is going to lay the baseline for comparison. So currently we have 6 as the earliest starting time for activity J. So 6 plus 12 gives me 18 at the end of this edge. And if I had not crashed K and just added the earliest starting time for activity K, which is 16 plus 4, I would have got 20 at the end of this edge. Now the difference between 20 and 18 is 2. So that tells me I can crash activity K by 2. Now 16 plus 2 is 18, and that makes 18 equal to 18, and that enables me to choose 18 instead of 22, which was originally chosen, and 18 plus 2 is 20, which is my new minimum completion time. Now if I was to record all the crashings, I crashed A by 1, I crashed B by 2, and I crashed K by 2. And A by 1, B by 2, K by 2, when the costs are brought into the picture, give us 1900, which is what I explained in part 1 of my video. Thanks for watching.